Hello, everybody. Another very important lesson, although this one's not going to be too long. I can solve quadratic systems algebraically using substitution method and solving polynomial equations. If you can't solve polynomial equations, you can't do this lesson. And if you can't factor, you can't solve polynomial equations. So, to be successful in this lesson, you must be able to factor and you must be able to solve polynomial equations. So your steps are here. I'm going to start by isolating a variable in at least one equation. It's helpful if you can get the same variable isolated in both, but you're not going to always be able to. Then you substitute one equation into the other, solve the equation. That's your Mr. X squared. That's your solving polynomial equations. And then you're going to substitute into one of the original equations to find the other variable. So let's start off with number one. It's pretty straightforward. I need a variable by itself in at least one equation. Well, yeah, I have y by itself in both. Great. So now I need to substitute one equation into the other. If y is equal to negative 2x plus 1, I'm going to substitute negative 2x plus 1 into y in the other equation. So instead of y equals, I'm going to write negative 2x plus 1 equals negative 2x squared plus 3x plus 1. That's your first step. If you can get past your first step, from here it's pretty much exactly what we did in the last lesson. Mr. X squared, he wants to party. Before he can party, all his friends have to come over. Plus 2x minus 1 plus 2x minus 1 negative 2x squared plus 5x. Positive 1 and negative 1 cancel. Party time! Bubbles! Factoring! Factor GCF dots. What's the GCF? X. So I'm going to factor an x out of each. I get x negative 2x plus 5. I set each factor equal to 0. I set x equal to 0. I set negative 2x plus 5 equal to 0. I solve each of them. Minus 5, negative 2x equals negative 5. Divide by negative 2. Negative 5 over negative 2. You can leave it as a fraction, but a negative over a negative becomes positive. Those are my two x values. Now, so I have x equals 0, x equals 5 over 2. Let's just clear some space. X equals 0, x equals 5 over 2. Now I'm going to substitute into one of the original equations, whichever one seems easier, doesn't matter which. Negative 2x plus 1 I'm going to choose. And I'm going to replace x with 0, and I'm going to replace x with 5 halves. I'm doing it with each answer that I got. Use a calculator if you need to. That's 1. And that is negative 4. Yeah. So my answers, when x is 0, y is 1. And when x is 5 over 2, y is negative 4. And instead of 5 over 2, if you wrote 2.5, that's fine as well. So it's kind of long, but conceptually it's not difficult. I substitute one equation into the other. I solve the equation. Once I get those answers, I substitute into one of the original equations to find the second variable. Let's do maybe two more. Maybe one more, maybe two more. I don't know. Let's do, yeah, let's do two more. Let's do number 6. I need a variable by itself in at least one equation. Yes, I have x by itself in the second equation. If I can easily get x by itself in the top equation, I would, but I can't. So I'm going to substitute one equation into the other. If x is equal to y minus 4, I'm going to replace x with y minus 4. So instead of x squared, I'm going to write y minus 4 squared plus y squared equals 10. To do y minus 4 squared, we do our box. whenever I'm squaring a binomial. We did that earlier in the unit. Y squared minus 4y plus 16. Y squared minus 8y plus 16. So I have y squared minus 8y plus 16 plus y squared equals 10. I combine like terms. Mr. Y squared, he wants to party. Before he can party, all of his friends have to come over. Party time, bubbles, factoring. Is there a GCF? Yes, there's an integer GCF. So we said when we have an integer GCF, we can divide it away and it's gone. Y squared minus 4y plus 3 equals 0. Can I factor further? 3 terms, trinomial. Y and y, first sign comes down, negative and a positive is a negative. Multiply us to 3, 3 and 1. Set each factor equal to 0. Y minus 3 equals 0. My y minus 1 equals 0. Y is 1. Now that I have my y values, I need my x values, so I substitute into x equals y minus 4, x equals y minus 4, x equals 3 minus 4, x equals 1 minus 4, x equals negative 1, x equals negative 3. When I write my answer, it's always x comma y, so my x comes first, regardless of which one I found first. Negative 1, 3, and negative 3, 1 are my answers. So again, I substitute one equation into the other. I solve the equation. Once I get my answer, I substitute it in to find the others. I really don't think there's anything more I need to do with you. That's the gist. That's what you need to be able to do. And I guess we can go over one more. Let's go over one more. Let's do number 11. And then this will be our last one. I need to get a variable by itself in at least one equation. Do I have a variable by itself in at least one equation right now? No. So I have to get something by itself. I'm going to do the top linear equation. I'm going to subtract x from both sides. That gives me y equals 5 minus x. Now that I have a variable by itself, I substitute one equation into the other. So since y is equal to 5 minus x, I replace y with 5 minus x. So I have x plus 3 squared plus 5 minus x minus 3 squared equals 53. I replace the y with the 5 minus x. Now I can combine like terms in this middle thing. Some people are thinking a 3 by 3 box. No. 5 minus 3 is 2 minus x. And now since I have two binomial squareds, I'm going to have to do two boxes. I suggest that you pause this and do this on your own at this point. But I'm not going to slow down. X plus 3, x plus 3, 2 minus x, 2 minus x, x squared plus 3x plus 3x plus 9, 4 minus 2x minus 2x plus x squared plus 6x plus 9, x squared minus 4x plus 4, x squared plus 6x plus 9, plus x squared minus 4x plus 4 equals 53. Combine like terms, 2x squared plus 2x plus 13 equals 53. Mr. X squared, he wants to party. All of his friends have to come over. 2x squared plus 2x minus 40 equals 0. Party time. Bubbles. Factor GCF dot. Is there a GCF? Yes, there's a integer GCF, so I can just divide it away. X squared plus x minus 20 equals 0. Can I factor further? Yes. Trinomial. First sign comes down. Positive and a negative is in the negative. Multiplies to 20. Subtracts to 1. 5 and 4. Bigger number goes first. Set each factor equal to 0. This is obviously a lesson you can't just go right into. You need a lot of prerequisite knowledge for this. That being said, it is a commonly asked Regents question. Now that I have that, I go to my originals, the one where I got the variable by itself, y equals 5 minus x. Y equals 5 minus negative 5. Y equals 5 minus 4. When I subtract a negative, plus plus, y is 10. Y is 1. So my answers, when x is negative 5, y is 10. When x is positive 4, y is positive 1. So it's definitely a long problem. But what did I do? I got a variable by itself in one of the equations. I substituted that into the other equation. I did algebra. I did arithmetic. I solved my equation. Follow my Mr. X squared story. That's your solving polynomial equations lesson, which incorporates factoring. And once I got those answers, I substituted into one of the originals to get my other variable, and I wrote my answers as an XY coordinate. This definitely needs practice, and you can't do this lesson unless you can factor and solve polynomial equations and do operations with the polynomials. You have to know how you do your box method. A lot of prerequisites for this one. But if you know all your prerequisites, it's really not bad. Practice, and then practice, and then take a note. Goodbye.